Hi, I'm Joseph from IT2102, and today's video I will answer the activities here in chapter 3. The chapter 3 is entitled Network Protocols and Communication. In this chapter, we will learn the use of generally accepted models that describe network rules and functions, as well as the standards that make networks work, and how communication occurs over a network. So let's get started answering the activities. First activity is on. By the way, it has chapter 3 has five sections. Section 3.0 introduction. Section 3.1 rules of communication. Section 3.2 network protocols and standards. Section 3.3 data transfer in the network. Section 3.4 summary. So there are three activities here in chapter 3, so let's get started. So first in section 3.2, 3.2.2.5. So activity, protocols and layers. So instructions drag the protocol standard to the TCP IP layer name as described. So internet is a, and by the way, these are the more protocols and layers: application, transport, internet, network access. So let's start answering. So Ethernet, it's the network access. So SMTP, so it's an application. IP is an internet. POP is application. TCP is transport. Interface device is network access. OSPF is internet. IMAP is application. DHCP is application also. DNS is also an application. And HTTP is also an application. So let's push it to UDP. It's a transport. ICMP is an internet. FTP is application. TP is application as well. EIGRP is also is internet. So yeah, it's all correct. So application includes SMTP, POP, IMAP, DHCP, DNS, HTTP, FTP, and BOOTP. Transport includes TCP, UDP. Internet, IP, OSPF, ICMP, EIGRP. And the network access includes Ethernet interface drivers. So yeah, that's all, and let's proceed to the next activity. It is in the section 3.2.4.5. 3.2.4. Yes. So activity part one: OSI layer functions. So are the layers and OSI layer functions functional descriptions. So these are the layers: application, presentation, session, transport, network, data link, physical. So segments, transfers, and resembles data. So it's application, application, application. Exchanges frames between devices. Exchanges frames between devices. So it's data link. Contains protocols used for process-to-process communications. segment. By the way, segments and transfers are transport. That provides a data path or route. So it is network. Bit transmission. Check it. That's alright. Here are the layers and its functional descriptions. Transport. Segments, transfers, and resemble transport. Segments, transfers, and resemble data. Data link exchanges frames between devices. Application contains protocols used for process communications. Network provides a data path or route. Physical bit transmission. Let's proceed to the next figure, figure 2. So, part 2, TCP slash IP layer functions. So, drag the TCP IP layer to its functional description. So, there are the layers, we'll just from them. So, and the TCP IP layer functional description. So, controls hardware devices and media. So, it's network access. Supports communications across device networks. So, it's the transport. Determines the best path through network. It's the internet. Represents data to the user and control dialogues. So application. So let's check it. And yeah, that's correct. So here are the layers and its functional description. Network access controls hardware devices and media. Transport supports communications across diverse networks. Internet determines the best path through the network. Application represents data to the user and control dialogues. So now we're done here. So let's proceed to the next and final activity. Okay, wherein we can find that in 3.3.1. Activity illustrate the encapsulation process. So let's hear the encapsulation process. Instructions: drag the PDU to the appropriate place in the stack to illustrate the order of the encapsulation process. So there are the choices: packets, bits, data, segments, and frames. So email data, data. It's data. Next is data. Next is segment. So next is packets, and last frames, and last but not the least, bits. And the encapsulation process starts with the data, and the next the segments, down to the packets, frames, and lastly the bits. So let's conclude the last activity here in chapter 3. This is how to illustrate the encapsulation process. And yeah, that's all the activities here in chapter 3. So for some conclusion and summarization, so chapter 3, network protocols and communications. Data networks are system of end devices, intermediary devices, and the media connecting them. For communication to occur, these devices must know how to communicate. So communication is very important in network protocols and these devices must comply with communication rules and protocols. TCP/IP is an example of protocol. So the first one example of protocol is that is TCP/IP, and most protocols are created by a standards organization such as the IETF or IEEE. The Institute of Electrical and Electronics Engineering is a professional organization for those in the electrical engineering and electronic fields. ISO, the International Organization for Standardization, is the world's largest developer of international standards for a wide variety of products and services. The most widely used networking models are the OSI and TCP/IP models. Associating the protocols that set the rules of data communication with the different layers of these models is useful in determining which devices and services are applied at specific points as data passes across LANs and WANs. Data that passes down the stack of the OSI model is segmented into pieces and encapsulated with addresses and other labels. The process is reversed as pieces are encapsulated and pass up the destination protocol stack. The OSI model describes the process of encoding, formatting, segmenting, and encapsulating data for transmission over the network. The TCP/IP protocol suite is an open standard protocol that has been endorsed by network industry and ratified or approved by a standard organization. The Internet Protocol Suite is the suite of protocols required for transmitting and receiving information using the Internet. PDUs, protocol data units, are named according to the protocols of TCP/IP suite: data, segment, packet, frame, and bits. Applying models allow individuals, companies, and trade associations to analyze current network and plan the network of the future. So yeah, that's the conclusion of chapter 3. So I hope you learned from my video, and thanks for watching. Till next time.